In this video, we'll create the clustering process in Rapidminer, and we'll just continue from where we stopped. That's the output of the correlation analysis. So at this point, after you have made your decision of which variables to continue and which variables to remove, then you can create your process. But for this particular demonstration, I'm just going to leave all the variables and try it. Later, if I don't get a good result, I might want to start removing the variables. So I'll go back to the design view. So this is where we stopped. So we'll not need the correlation matrix operator again, so I will delete it. But we need to do two things. First of all, where we are selecting these attributes, we need to include an attribute, that's the customer ID, as part of the attributes. So we did that because when our clustering result appears, we want to be able to identify which individual is in a particular cluster, because that is how we know how to target them and offer them the marketing, solution, or the marketing that we have customized for them. So I will now, after I've included that, I need to set the role as an ID. So I'm going to bring set role operator here. So I'll click on this and select the attribute name. The attribute name is customer ID. I'm not using it as part of the clustering attributes, but I want to use it to identify the individual in the clusters that comes out as the output. So I'm going to set it as ID. Then I'm going to bring in the k-means clustering operator. And I should also say here that like we said, there are several ways of determining the k, but we have chosen to use domain knowledge. So we are just going to be selecting the k that has been recommended by the domain expert. But we are also still going to try the approach of experimentally testing different keys and then check the validation results. That's the average, centroid distance, and then see how the cluster results fare. So the one that has the best results will be the K that we will settle for. So for this k-means operator, we probably need to set some values. That's the K. And that's the most important value anyway. But like I always say, if you click on this help for this k-means operator, you will have an idea of what these other parameters are. For example, the maximum number of runs. You might want to also know what that is doing so that you know how to set that parameter, even though I just left it as default. But it's a science, it's an experiment. You have to try different ones and see which one gives you the best. So still on the clustering, I want to use k is equals to 5 first. Or let's even start from k is equal to 2, and then let's see. That's at least you cannot have k is equals to 1, because then there's no cluster. So let's see k is equals to 2 and then see what happens. So another thing we should also talk about here is the measure types that we talked about between records. Remember, we said there are two measures distance that is important for our k-means or clustering. So we need to look at what we are setting for that. So if you click on if you click on this k-means and you check this help, you'll be able to have some of the ideas of how to set these parameters, that's these measures. So there are different measures. So you can see that there are different, we have the mix, we have the nominal measure, numerical measure, and so on and so forth. So that is there. So we are just going to pick the types of measures. So I'm going to pick the numerical measure because all our attributes, uh, they are numerical attributes. We've converted all of them to numerical. So I'm just going to pick the numerical measures just like we explained in the theory part. And then it also has, the numerical measures has, other types of metrics. But like we said, we are using the Euclidean distance because most of our preprocessing was directed towards, having maximum results from Euclidean distance. So we are using the Euclidean distance, which is there by the default. So the next thing that we want to do now, after setting the parameters for the k-means clustering, but it's like I said, it's always advisable to please go through the help so that you know what exactly these operator settings are and what is what is best for you. So the next thing now is to be able to check the performance. So for that, I'm going to bring the cluster distance performance. So this helps us to check the distance between the clusters that have been formed. It has to be very separated for us to have good results. So the cluster distance performance is right here. So I'll bring it out and connect it cluster to cluster and this to the output. And let's see all the outputs available. I just want that to go right here, there. And then that is also going to the second one. So we want to see the performance results, we want to see the resulting clusters, and so on and so forth. So with that now, we have a pretty good setup. So let's run it. We can see that by default for the performance, we have average within cluster. So you can select any other one if that is not the one you want. You can select this too. We talked about this in the theory too. So it's still running. So it's done running, but it's telling us that we don't have any results. That's previously, but now it's giving us some results. So we are looking at two clusters, and this output, first of all, that's the cluster model output, gives us the idea of the number of items that we have in each cluster. So now for the first one, we have this. For the second one, we have 4, 2, 4, 1. Given that, we can actually try to, okay, this is the description. We can try to look at the graph just to explore each of the outputs. Before we go to the graph, we can look at the folder. So this folder is telling us which of the transactions in which of those clusters. So to see the transaction in each cluster. We extend it just to see what's going on, but it's quite that there are many, so I don't want to scroll down. So we can actually also look at the graph. Okay, so just to give us an idea. Then we can look at the centroid table. Okay, so this is the centroid table for the two clusters. And then let's see the plot. So we can see the plot. So if we look at this now, this is not a very good, it's not a very separated result, because we don't have, if we have two clusters and they are both together. So this is not there's no separation right here. So if they are separated, we can be able to start characterizing each of the clusters. But we need to try to see, some other K, so that we can be able to see if we will get a better separation for the clusters. So this is where you actually, profile the clusters that have come up. But we cannot profile these ones because they are almost giving us the same results. So let's try another value of K before we go to evaluating the clusters. Let's just try if we can get better results. So I'm going to go back to the design and try K is equals to 5, for example. So let's run this again. It's still running. Okay, so it's checking the performance. Okay, so we can see that for this, we have all these items in the different clusters. But let's just go right to the plot and see whether we have some separation. So, well, not much of a separation, but at least we have, if we look at the clusters are represented by 0, 1, 2. So this is the blue one. This blue one is the cluster 0. So if we want to explain this cluster, for example, we just look at what makes it distinct. So if you look at this blue now, we can see that for tenure is very low. So that's minus 0.5. And every other thing happens to be the same with the other clusters. But if we look at the cluster 2, we can see that their age, for example, that's the green one, it's very high, and so on and so forth. So, but this outputs is not, the clusters are not really distinctly separated. So it's not giving us a very good outcome. So we can't really profile the segments as it were. So we are looking at the real business problem that we are going to be taking in the next video or in the next exercise on clustering, to have a better separated cluster, and then we can be able to profile them. But we will still try to interpret whatever this looks like, that are just like I've just interpreted. So in the next video, we will look at how to validate and interpret the clusters, whether it's as good as what we want or not. So this is just determined by the data. So if, for example, we want a better, separation, we can go back to the result of the correlation matrix and remove quite a number of attributes that have even any correlation at all, and then let it be only those ones that has correlation between 0, that's positive 0, 0.0 to positive 0.2. 2. So just use only those ones, even if they are 5, 6, or even if they are small, they might be able to give us a better result. So that's why we said the science, the data science that is iterative. You have to go back and forth until you get what exactly you're looking for. And if you don't get it from that data, you probably need to look, inwards again at your data collection process and try to get another data that will give you a better result.